Hi, good night, and well, in this video, I'm going to be covering three questions that have been given, well, apparently been given students problems in the CXC multiple choice maths papers. Okay, so these questions were sent to me by students, so let's jump straight into it. The first question, question one, right? So this here is the diagram for the question. What they wanted the student to do was find the perimeter of the regular hexagon. First of all, well, we know perimeter is the distance along the shape. So they want us to find the perimeter of the blue part of the shape. And a regular hexagon, well, when you have a regular shape, it means all the sides have the same length. So for the blue hexagon here, all the sides have the same length, which means all the angles, all the interior angles inside the hexagon will also be equal. For example, what do you call a regular triangle? A regular triangle means all the sides have the same length, but we call it an equilateral triangle. And in an equilateral triangle, all the sides are the same, but also all the angles are the same. We know each angle from primary school is 60 degrees. So there's a brief review there. So here's how we're going to go about this question. There's a formula we need to pull out. They usually introduce it in Form 3. If you have any three-sided figure in the world with a triangle, all the interior angles add up to 180. Any four-sided figure, for example, a square, a rectangle, a parallelogram, all the interior angles add up to 360. So if you have a five-sided shape and a six-sided shape, the total interior angles will add up to more. So there's actually a formula. So if you have a shape and you want to know how much all the interior angles add up to, we just use this formula. N minus 2 in brackets multiplied by 180. So today's shape, the hexagon, has 6 sides. So all we have, N represents the amount of sides the particular shape has. So since it's a hexagon, we are going to replace N with 6. So the formula says it's N minus 2, so 6 minus 2, which will give us 4. And when we get that, we have to multiply it by 180, which gives us 720 degrees. That means if we add up 1, 2, 3, 4, 5, 6 angles, all the angles would add up to 720. But keep in mind it's a regular hexagon, which means all the angles are the same. So that means each angle within the hexagon itself is 720 divided by 6, because we're dividing the total interior angles into 6 equal parts. And 720 divided by 6 will give us 120. So that means that this angle is 120, this angle is 120. Just give me a few seconds here. This angle is 120, this one is 120, 120, and 120. All right? Next, since it's a regular hexagon, you see this line here, the 8 centimeter line, which was given to us by the examiner. This line will cut the 120 exactly in half, which means that this angle here is 60 degrees. I could probably make that look a little better. So I'm just going to move the 120 out of the way, and this half of the 120 is 60 degrees. I'm also going to move this out of the way a little bit. So let's pretend we have another line here, right? So if here is 60, right? That means, remember, this line here now will also cut this 120 in half, making what? Making this angle also 60. And all the angles in a triangle must add up to 180. So 60 plus 60 is 120. 120 minus from 180 will give us another 60 degrees. So this is obviously an equilateral triangle because all the angles are 60 degrees. So that means if here's 8 centimeters, then over here is also 8 centimeters. So I'm going to just put this over here. And that means over here is also 8 centimeters, which is the most important part. So if from here to here is 8 centimeters, that means all of them are 8 centimeters. So just neglect this note here, we don't actually need that. So the perimeter of the shape is 8 centimeters multiplied by 6, because the hexagon has 6 sides. So it's 8 multiplied by 6, right? I believe 8 6 are 48. Double checking. Yes, it's 48 centimeters. So in the multiple choice question, this 48 centimeters should be either choice A, B, C, or D. Okay? So, but the first thing was to kind of prove to yourself this was actually an equilateral triangle. And if here was 8, that means over here would also be 8. So I hope that was helpful. That was question 1. Question 2, right? I'm going to get a diagram for this one. Oh, this was a pretty easy question. I'm not too sure why so much people message me about this question. Question 2, find the area of the shaded region, which is basically the blue circle over here. Now, I think I know what was the problem. This 1 meter probably confused everyone. If you notice, there's a big circle here, and inside it, there's a smaller circle. To find the area of the circle, we're going to take let's look over here for a few seconds. We're going to take the area of the big circle and the area of the small circle and just minus it. And if we do that, we will be left with the blue region. So the area of a circle is pi multiplied by radius squared. This upside down V means to the power 2 or squared. I'm using notepad, so you can actually, the 2 can actually hover over the R to make it look like R squared. So this symbol here means to the power 2. The big circle, how much is the radius of the big circle? And I think that is what was confusing students. Think about it like this. Let me zoom in here. If from here to here is 3, and this part is 1, then the total radius of the big circle is not 1, but 4. 3 plus 1. So let me see if I can show you how to visualize this. If I bring this up here, you will get the 3 that will add to the 1 to give you 4. So the area of the big circle is pi multiplied by its radius, which is 4 squared. 4 squared is 16. 16 by pi is pi squared. 4 to the power 2 is 16. 16 by pi is 16 pi squared. Sorry. And for the small circle, well, the radius is just 3. So it's pi multiplied by its radius squared, which is 3 squared. 3 squared is 9. So 9 by pi is just 9 pi. So the final area is the big circle, which was 16, minus the area of the small circle, which is 9. 16 minus 9 is 7. Okay? So that was question 2. So let's see what other multiple choice question was given the students problems. This one here I found was super easy. What the examiner did, they gave you a circle. And the blue section, well, I made it blue, but you know in the exam it's going to be black and white. And the angle of this sector was 30 degrees, and the length of the arc only from A to B, the curved part, was 5 centimeters. So this was the question here. Given that the arc AB is 5 centimeters, find the circumference of a full circle. First of all, a circle is 360 degrees, and 30 degrees gives us a length of 5 centimeters. So how much 30 degrees can fit into 360 degrees? So it's 360 divided by 30, which is 12. So that means 12 of these blue circles can fit inside, sorry, 12 of these blue sectors can fit into the entire circle. And each sector has a length of 5. So that means the circumference is 12 multiplied by 5. So 5, if you have 5 here, 5 here, 5 here, and we do it 12 times, it will go around the circle, which is the circumference. So the answer for this one would be 60 centimeters. Okay, guys, so these were 3 questions that was sent to me over the last couple hours. And, well, I hope you understand them now. Take care, and good luck in your exams.